Hello again. This time we're interested in the reaction of silane with air. So when we make some silane directly by putting this in, we see the reaction immediately. Silane reacts with oxygen in air instantly, it bursts into flames and kind of explodes. It's very similar to the reaction of methane with air. We get a flame, it's a little bit orange, but in this case the reaction takes no heat to start it off, at room temperature anyway. So when a bubble comes to the surface it bursts into flames. That's why I'm making such a small amount at a time, so we'll see a few little flames catch here and there. I'll show the equation somewhere on the side so that you can see that it's exactly the same chemical equation as it would be with methane, just that the carbon is replaced with silicon. The difference being that the energy required to break the bonds in the silane, in the SiH4, is very small, so the reaction can start very easily. Although the energy gained from doing the reaction is much the same. And all of the other things are much the same. So the only major difference is just the energy required to start it, and it really comes from the bond between the silicon and the hydrogen being easy to break, which it happens in this case just with the heat. There's no light involved. We'll let it go a little bit longer and I'll put the equations here. This is to demonstrate that the speed of the reaction and the amount of energy of the reaction and the ease of starting the reaction are not necessarily the same thing. So we can have a reaction that is slow or fast, and a reaction that is easy to start, starts on its own like this one, or is harder to start, and any of those reactions can give out more or less heat. This particular reaction gives out quite a lot of heat. It is easy to start, and the methane reaction gives out just as much heat, but it is not as easy to start. Both of them run away on their own if they're mixed, and so if you mix methane with air it can explode, and if you mix silane with air it explodes on its own, which is why you normally make it to demonstrate this, which is what I'm doing here. It's a reaction of magnesium silicide and water which generates silane.